I, J. Haimauti of CSC Department, is feeling privileged to introduce today's resource person, Mrs. Swarupa Akanuri, Director Engineering at Anthem. She has total of 21 years of experience in industry as an analyst, advisor, business intelligence solution architect, and director engineer. She completed her BTech from JNTU College of Engineering, Hyderabad, and worked as software programmer in TCS from 1998 to 2001. She is a Teradata certified professional, Informatica certified developer, IBM certified solution expert in DB2, UDP version 7.1, database administration for Unix, Linux, Windows, and operating systems. Mrs. Swarupa Akunuri leads enterprise architecture for data and analytics at Anthem, which is a health insurance company, along with architecture and delivery of cost of care platform and platform analytics platform. Cost of care platform helps in analyzing the expenses, projecting the trends, profit and loss, etc. The product analytics platform helps with product profitability reporting and help Anthem in tuning benefit design, optimizing the cost and packing products that helps to improve the members' health. Both of these deals with the billions of data volumes and with the complex ETL frameworks. We are very happy to have you as a resource person for today, madam. Now, I would also like to introduce Mr. Sai Natishan, who is a product manager and lead architect at Anthem, who has completed his MBA from Chicago Booth School of Business. He leads delivery of AIML models of data analytic applications on cost of care and clinical platforms. He collaborates with business in developing responsible AI models that helps with predictions and help improve the members' health. Thank you for giving me this opportunity.
Now I request Swarupa to take over the session.
Good evening, everyone. Thank you for giving me this opportunity to talk about healthcare AI, part of your FTP development program today. Thank you, Ranjani, Mrs. Ranjani, for giving this opportunity again and be able to share what we have learned through this journey. We will keep it interactive so that everyone gets a chance to ask questions as well towards the end. Thank you for the kind introductions as well. Like mentioned, I'll be mainly covering the overview of how artificial intelligence is transforming the industries right now and the future of it, which will really help from, I think, encouraging the students and coaching them because we are just scratching the surface of artificial intelligence and machine learning models right now. The more we tune it and the more we work on it, there is more and more automation and predictions that can be done that can have a positive impact on various domains that we work in. And my colleague Sai, he is the primary lead and guru of our ML models here at Anthem, and he will cover more on the technical side and the skills and what is really needed to acquire the skills as well. So we both will partner and cover this session today. And the primary focus, as stated, or as I came to know from Mrs. Ranjani, is this is more of a faculty development program. So we will tailor more towards how can we encourage students in acquiring the needed skills. How can they learn the passion towards data and the skills? Because first you need to have passion towards what you're learning. It's not just a skill that you can learn and get a job, because then the sustenance is very low. Only when you're really enjoying what you're doing, you will be able to grow and do more and excel. And part of machine learning or artificial intelligence surrounds data. So it's, I think you need a lot of skills, but really you should have passion towards the data and understanding the data and the domain, because that is 90% of the work. Statistical models is only 10%. So As we get closer to the sessions, we'll talk about various ways we can encourage the students in acquiring the needed skills, as well as having a passion towards sometimes impatient tasks, because part of it is problem solving, debugging, learning the data, which is the long pole in the tent, and it takes a while to really get there and getting a good model developed. So let me share my screen and start presenting today's session, and then Sai will cover the technical portions and the skills portion, and then we can get back to question and answers. Can you see my screen?
Yes, yes.
Yes,
Okay.
ma'am.
So the topic, like I mentioned today, is AI ML driven solutions for healthcare. So very briefly, the definitions: artificial intelligence, the AI portion is a general field discipline of study that focuses on mimicking human or animal intelligence in machines. A broad field that encompasses everything, including machine learning. So the one cool story about it is when I was studying BTech, this was like in 90s, 94. I had a couple of students who are very, very intelligent students who used to carry a book called Artificial Intelligence back in 94 itself. And at that time, I remember he's like the topper of our university. I remember him telling me that, Swarupa, AI will be the future. That's why I'm reading this book. And at that time, AI was not covered part of our curriculum, but this person, his name is Sharma, he used to carry AI book and tell basically every evangelize about artificial intelligence to the class. And I wondered back then in 94, what is AI, how it will be used. But actually, so many years later, I don't know, almost like 22, 23 years later, I'm starting to see the evolution of artificial intelligence and the application of it. So this is not a new concept. It is there for a while, and I know the mathematicians and the all the brilliant people realize that artificial intelligence has so much scope. We are just getting to application portion of it, and I see that there is a very, very, very bright future. If I heard about it in 94 and I'm seeing that it's evolving for our students now, we can encourage them to tell that that will be the future for generations, because there will be more and more evolution of these technologies in the future. So this is a very good skill set to stay focused and acquire. Machine learning portion, focused field of study, which primarily utilizes mathematics and statistics to enable artificial intelligence. It heavily relies on data. And machine learning, I think probably very high level, is classified into three types of learning. Supervised learning, which is the most common use case, which helps in predicting the stock prices, or which is used in the self-driving cars. Unsupervised learning, it is pattern recognition and general research. So it kind of improves itself. This is more used in like traffic signals, or taking pictures and trying to come up with predictions based on that. Reinforcement learning, controlled environment to explore all possible trajectories, utilized primarily in robotics. So how is AI/ML, or why AI/ML for healthcare? When we say healthcare, just I want to briefly touch upon where me and Sai work. It's called Anthem, which is the largest health insurance company in USA. So in United States, everybody needs to have health insurance to go see a doctor. So that's how the system works here. And so through as part of health insurance, because we offer health insurance, we process the claims and then provide payments to the providers for the services they had. So we, because of the health insurance company, have access to their data, which includes the members, their membership details, their age, their demographics, where they live, and their health conditions, because either they're filling health assessment form or because of the claims, because of seeing the doctor and seeing what type of claims, what type of conditions they had. We can look at what are they having, as well as we have access to you know um, the various age bands and the various populations, and how different populations, different age groups are doing health wise. And mostly we see the claims or conditions getting worse in senior population or older. And the overall, when we say healthcare, it's not just paying the claims. Our company, or any health insurance company, the big ones, they look at it as holistically a member and their health. And how do we improve? It's not just about paying claims. So how do we consider AI ML for healthcare, or where we are is the main topic today. But before we get there, let's look at various examples how AI ML is utilized heavily today. So the natural language processing portion of AI ML is utilized in Alexa and Google Home. Pretty much, I believe you are aware, the Alexa is a device which responds to our voice commands, and kind of is same as Google Home. And there is, I think, Amazon has a product called Echo. I believe they're used in India too heavily, or India has come up with its own version now. So it is very similar, and it kind of based on voice recognition. It connects TV, or it would play songs, and it will tell whether it will Google for us. It does various things, and natural language processing used part of it. Even Alexa, lately they're improvising it. So based on what we are asking, like we say we asked for music few times, the next time when we call Alexa, it says, do you want me to play so and so music? So it kind of stores it and also tells what I'm looking for. So pretty much it's reading my mind through AIML. Second portion is image recognition. It's image search, optical character recognition, and self-driving cars. The Tesla self-driving cars kind of use image recognition part of AIML. Predictive modeling, most common everywhere, from targeted Facebook ads, Amazon recommendations, to robotic trading boards. Who benefits from these developments in AI/ML? Companies such as Amazon, Google, Tesla, Facebook, these are the top tech companies that you all know, use these technologies to improve their businesses. Wall Street firms utilize algorithms to predict market trends. Of course, there are several companies that create and utilize these technologies to improve their product safety, increase their customer satisfaction, and make better and easier lives of people. Mostly it's for their profitability, but there are companies who kind of look both ways, where a member or a consumer can be benefited too. Now, how do we use AI/ML in healthcare? While we predict stock trends, can we not predict a member's health trends and risks? While we can perform image recognition, can we not utilize it to improve X-rays and scans? Truth is, very little has been done in AI/ML for healthcare. We're just scratching the surface. The reason is healthcare data is sensitive. It's not like public data that you can gather from Google search engine, or Facebook ads, or looking at your search history or your browsing recommendations. It is more of um, it's more of members' health. So a caution needs to be taken when you kind of analyze members' data. Also, when you're predicting members' health conditions, it is a very sensitive thing, because you can predict something and it might not happen, and you can outreach to that person and cause panic. So that's why we call it responsible AI. So that is why it is not as easily used, but it can definitely make a huge impact. Can you hear me better? I'll just take a pause and get feedback.
Yeah,
So,
we can hear you.
okay. How can we use AI ML in healthcare? Almost all types of machine learning has applicability and use in healthcare field. Predicting yes, no, and percent likelihood that is used by Amazon for displaying products can be transformed to predict yes, no, and percent likelihood for a person to have a heart disease. Object detection recognition technologies that is used to apply brakes in Tesla can be transformed to identify micro-sized tumors and anomalies in X-rays and scans. Natural language processing used by Alexa and Google Home can be transformed to perform medical transcription. So you can see how we can apply the various technologies in healthcare as well. So is it that easy? Why isn't it already done? There are a few key differences between existing use cases and corresponding healthcare use cases. The above existing use cases can be performed by humans, thereby enabling machines to learn. Data either exists or can be generated. But healthcare data, like I told, isn't easily accessible or standardized. Finally, most of the above general use cases have significant room for failure. Displayed wrong product, showed wrong ad, picked incorrect word while listening. Nobody cares, nothing wrong. But healthcare, you can produce a false negative and endanger somebody's life, or false positive. So it has a lot of sensitivity. So even though sometimes that there is a prediction that there is a risk, you have to be very cautious in communicating that risk. So our use case today from healthcare AI is a myocardial infarction, which is nothing but a heart attack. Um, so a person one, for example, in 2015 had hypertension or blood pressure, and the same person, that's the journey of the person, in 2017 had diabetes, and it continues, and he had heart attack in 2018. Second person in his journey, 2015 he had hypertension, 2017 he had diabetes. One good thing that happened is sometime between 2017 and 2018 he happened to have a ECG which detected his abnormal heart rate, and he was saved from having a heart attack. So this ECG at this time frame made a difference in this person's life. Now, based on this, the third person, now again similar pattern, which is a very common pattern, especially in India. India is the diabetic capital of the world. So um, usually diabetes, and they call it comorbidity conditions, come with hypertension. So the same person now had diabetes again. Like I said, it's a pattern. Usually one happens after the other. Now, in where we are, can we predict what will happen to this person? So if you see this pattern, right, person one or person, like, 10 number of persons had heart attack based on this pattern. But if we had a ECG, a heart attack was prevented. So seeing these data patterns, right, can we predict what will happen to this person now? So that's how AI ML can be implemented. So what is the problem? So members' life or death. Um, about 647,000 Americans die from heart disease every year. This is one in every 4 deaths. This is the data collected from CDC. The leading cause of deaths in United States, the first one is heart disease, second one cancer, third one is accidents, and the fourth one is lower respiratory, like lung related issues. Fifth one is stroke. So that's why heart attack was chosen as a use case to study using AML models. Heart disease is not only the leading cause of death, but also a significant consumer of cost, with cost distribution per patient per year ranging from a few $100,000 to a few $100 to a few 100,000. Heart disease treatment could be as simple as lifestyle changes, eating healthy and exercising, all the way to coronary artery bypass surgery. Treatment costs for angioplasty costs 6 times, while as coronary bypass surgery costs 20 times. So, so what we are trying to say is, because we are a health insurance company, it's not a member himself that is incurring the loss, but as a company, our cost of care has increased tremendously because of, the more the member neglects his health or her health, the costs rise, because surgery is definitely expensive than stunt, and then x-rays and ECGs are much cheaper than surgeries if they can be used to prevent it. So where do we get our inspiration from? Again, to be able to predict and reduce the cost for AI/ML models, like I explained, right? So if we can know members' history from the data, and if we can try to, influence member to be healthy, then probably, we can use at least ML to kind of target the audience. And our inspiration really comes from a few cool things that have been already done. One is Amazon's recommendation engine. So what Amazon does is, as we are buying, ordering stuff from Amazon, it keeps all the user purchase history in the database. It also, so say I bought 10 products, it also looks at other member who bought similar products like me, and then it combines. So for example, iPhone 11 case is what I searched for. It is also looking for other members who also searched for iPhone 11 case. And then it kind of say this person, the other member, I haven't looked after iPhone 11 case. I didn't really look next, but this other member in the past, after iPhone 11 case, looked for a phone charger. Okay. So this is what it comes up with the recommendation. So first you have an iPhone, probably you bought somewhere else, but you came to Amazon to look for 11 case. But then this person, other person, either looked at a charger or a screen protector or a tempered glass. Based on this other person's data, it recommends that for me. So that's how it works. So, and it says, I actually use this feature a lot because it makes my job easier. Sometimes I don't even realize that once I buy something, I need to have this. So based on recommendations, I'm like, yeah, it is good to get a cover. It's good to get a case, kind of a thing. So it also bundles them and gives a price saying, hey, if you buy 3 of this is how it will cost. So this is how the recommendation ML algorithm works from Amazon. Based on that, what is our solution? So with data, one of the things is preventive care recommendations engine. So this is, again, the focus is prevention. If we can stop a member from having heart attack, it is twofold. It will help the member, it will help the company save cost. So that's why for health insurance and for us, prevention is our number one priority. Members' health, if we can keep members' health first, then it works both ways. It helps companies save money. It helps member, live longer and stay happier. So to be able to do that, the 3 main data sets that are the, checklists that we need to consider, or, there are like standard codes that come with the data. We call them ICD-10 codes. They are part of how a provider or a doctor sees. They kind of put some standard codes. This is how, I don't know if you can relate this to in Indian healthcare system, but this is how it works in USA. But the codes are same across, and I believe the same codes, the standardized codes, can be used in India or any other country too. So the ICD-10 code indicates what type of exam the member had. The CPT codes indicate what type of procedures they had, and there is one more set of codes called diagnosis codes. It tells what condition he had. Um, we in parallel also have member disease and demographic history based because of the membership, and we combine the lab data for whatever labs they had part of their journey. Maybe the person that we are analyzing is in the later part of the disease progression, but we kind of have the lab data historically also, or we might have a member who is in the early portion where he's having signs of hypertension, but then we can see based on the members who had hypertension, diabetes, and other conditions and what happened to them, just like Amazon, right? Based on other members in history, how it predicted. Our idea was the same thing, to combine, the members' history and the similar patterns and be able to predict it. So how does it work? The first piece is member identification. So this is where we are getting into now, as we know the use case and how we can, target the members. The first thing is identifying the people. So that's where, there is, say, Anthem has, or any health insurance company or anywhere in healthcare, you can have any number of people, but you need to really focus on people that have historical heart disease data. So first, train your ML model with historical heart disease data. Find people with lifestyle diseases, so who are smokers, or who are leading a bad lifestyle, who never saw a doctor in their life. They are really the targets for outreach, or that can be focused to to gearing towards a healthy lifestyle, and also people who are at risk, sometimes just genetically, or because of their lifestyle. So that once you kind of narrow the historical heart disease data, as along with people having risk or bad lifestyles, you kind of get past the test. You run your AI/ML model for recommendations, and you identify the recommended test. Then it will basically, the model algorithms will tell you whether they are 1 or a 0, whether they are probable, candidates for having a heart attack, or they passed it. And there are different ways to validate it. We kind of validate it. Basically, since we already have claims with people who had heart disease, we can run our test as if they never had it, run the model as, to kind of shift the history backwards, run the model, and then look at the predictions and compare it back with whether, whatever it recommended, and whether the member had a heart attack or not. So that's how we validate and run past it and make sure we tweak it and make sure it's working as expected. Then the third part is we pass this data to our marketing channels that work with outreach. So basically they reach the member through various channels, either through app, or when they're logging to our health apps, or emails, or phone calls, and then kind of encourage them. We won't basically tell them, they're going to have a heart attack or so, but encourage them to say, hey, we have noticed that it's time for your ECG, or we have noticed that you haven't gone to a doctor in a while. Why don't you go see a doctor? Or, that type of positive encouragement to make sure that they're seeing the doctor. The cost benefit, just avoiding 10% of surgery would save millions of dollars. The population benefit, while we are targeting a significant reduction in surgeries, we are hoping to help members understand the risk of heart disease. Long-term benefits, research like these need not just benefit the company or country that performs the research, but it helps with other institutions in the world. So the healthcare practices, they can be shared. It's more of, sharing the good things, because at the end, this type of things have a social value. Whether a person buys an iPhone case or not really is more personal, and it's only benefiting that one member. But research and, saving people lives has impact on our society and in the world. So you can see the difference. Studies like this, models like this can help not just our company but others and the people in the especially in the third world countries where there is not much outreach, not much awareness of best health practices or lifestyles. So that is why I feel like healthcare is so powerful. You're directly impacting members' health through research like this. It also increasingly in the digital driven world drive initiatives to help transform population behavior. Okay, so now where to start for this? Like I think I briefly covered the domain portion of the use case. So again, it's like a little bit way of organizing the data. First, like I said, identify health data in a more organized and way. Then gather data from available sources and analyze. So one thing as I'm going through the steps, these are all the various steps in AIML. And gather and analyze, build AIML model, identify top 10,000 members. So say you have 100,000 members that were run through the model. Top 10,000 are kind of identified for the pilot just to see how it works. Analyze and produce recommended tests and outreach to the population with the recommendations. So these are in general the steps for healthcare AI, especially in the prevention of heart attack ML model. But I would tell, as you're coaching the students or any team member, the largest amount of work happens in these two steps. Developing a model, running these happen very quickly. Writing the code also, it's not like 10,000 lines of code. These are pretty much, once you identify a good data set and analyze your population and you build your variables, this is not the heavy lift. These run pretty fast. But to be able to develop good models and to be able to get good output, right? This is the long pole in the tent. So when you are working on data analytics or insights, the biggest strength that you should possess is analysis. Any student, you should first enjoy analyzing the data. So that is not something you can skip and get to writing the models, because then you are writing something that you have no clue what will happen to it. So it's the part of a package. Whoever is working on it, on the AIML in their long-term goal or a career in they want to become a data scientist, the primary skill that they should have is they should enjoy analyzing the data. They should enjoy understanding the data. They should enjoy gathering the data, writing SQL, all types of data exploration and analysis in various kind of tools. Being able to hustle with it and say, okay, this is not working. Let me try a different data set. This is not working. This is where 80% of work happens. The remaining 20% is training your model and then, tweaking, testing, validating, and then outreach. So the opportunity, I think I skipped slide. Just let me see. So how to scale? Realize the success rates and potential savings. Roll out the scale, and once it is a successful user story, you can implement the same model for other diseases like digestive system, kidney failure, liver cirrhosis, pancreatitis, and evolve it. So there's always room to improve it. So opportunity. Healthcare AI is one of the most pursued exponential technologies today. The CDC and healthcare.gov together enable data for research. So the government provides data because of the sensitivity. We can't use our own members' data, but there is generic healthcare data that the government is providing, like dummy data sets to improve it. Models in the healthcare field with some mentoring could provide students with strong practical learning experience. The impact is huge opportunity to help lives of the people healthier. Um, that's all I have for today. Thank you for your time. I'm going to pause for a few questions, and then I'm going to pass the ball to my colleague Sai, who has actually worked on developing these models and has not only just one model but has developed multiple models. So you can get to ask more technical questions or any type of questions to him. But any questions on what I presented so far? Okay, if you are good, I'm going to pass it to Sai to do the rest of the presentation. Thank you.
All right. Can you hear me okay, Rupa? Just to
Yes.
confirm. All right. Let me share my screen. And I'm thinking, okay, I got the right screen. Okay, so let me know if you're able to see it. This, you should be able to see a presentation.
Yes, we can see it.
All right. So I am going to go into presentation mode and start. So I think that was actually like a pretty awesome overview. Thank you, Rupa, so for getting started. And I thought like I'll actually dive a little deeper into more specific use cases, what kind of models are there. And I in fact saw like a question in the chat window about AI being just deep reinforcement learning. It is like much broader than that, but I believe there are we can actually dive deeper into like some of those questions as well as we can as we get into more detail in this presentation. And Rupa actually had like a nice story to say. So I actually tried to create my story as well. So like in general, like so there were like when we think about AI, the expectation from like people is like very different from like what the reality is. And I was like really impressed like by when Rupa mentioned like she had like friends um, who were talking about AI when she was in college. I mean, like I actually, when I went to college, I never spoke about anything or AI or like any of the cutting edge trends. I mean, like, so that's like kind of really cool that she actually had that kind of an exposure and cohort. So this is the story that I have, right? Like, and this is kind of a real story that happens with me almost every week. So I get like customers or like um, people that consume like my intelligence saying something like this, like, can you predict like the closing price of these 100 stocks using past trading data? So it's like any other question, really. Can you predict who will get a heart attack? Can you predict who will fall down today from the stairs or something like that? So and then like, yeah, it's possible. I mean, like maybe not exactly who, but like, so my answer is something like, yeah, sure, I can give you some sort of predictions and like a confidence interval using like past performance. And then the next question is like, okay, will it be accurate? Like, I mean, within like 1 or 2%, like, would you know, like if the stock will go up or go down and like to what price and whatnot? So, and usually my answer is like, yeah, maybe not that accurate, right? Like, I mean, we can do some sort of predictions, especially when it comes to like closing price for like a specific date. We may not be like that accurate after all. I mean, if I'd known that, I would have been very rich. So then the next question is like, what do you mean? Like Tesla is like delivering self-driving cars. Alexa can like listen to me and like place my order, and like they feel like I have a very incompetent team that is not able to do like a simple prediction. So and then I'm like, okay, what can I say? Right? Like so, and I say like, okay, I mean, Tesla can provide a self-driving car, but I can drive too, right? Like humans can drive, even can also understand instructions. If one of you like have to order something, I can definitely take that and like place the order. But can one of us in this meeting actually predict the stock price for like about 100 stocks with like 1 or 2% accuracy for tomorrow's closing price? I bet probably we will not. So this is usually my response to them, and like that's kind of the reality too. Like what we can do, we can teach the machine, and the machine can learn. And maybe a tad bit more than that. We are probably smarter in certain ways. We can actually learn by experience. We can learn. I mean, like the question was like, what is AI and is it deep reinforcement learning? I'd definitely say like it's a major portion of it, because like we can we learn by, as humans we learn by deep reinforcement learning, but the machine aspect of it is still, um, the environment is not so controlled that we can actually learn so much using deep reinforcement learning, right? So with that story, let me actually segue into like what types of learning is available today. So we have three fundamental types of machine learning. The first one is supervised learning. I mean, and I believe already Rupa said like it's the most popular, most common um, type of learning that's used today. Unsupervised learning is also available. It's not as common as supervised, but it is quite common. Reinforcement learning is actually an emerging technology, and it definitely is in like very premature stages as of today. So when it comes to supervised learning, I mean, or what the differences are between these three. The differences are like actually very straightforward and very simple. So when it comes to supervised learning, we have what we called labeled data, all right? And I have a picture here. So if you look at like the top picture, which says supervised learning, and like the picture that's like the brain.
Sai,
Yes.
sorry. Well, I think the voice is coming little muffled.
Oh, it
Uh,
is.
yeah, is it? I'm wondering if it's the headphones.
It it is the headphones. I mean,
Can you?
sometimes it just is for a little bit, but is it too bad or is it getting
I
better?
mean, can others comment, please? If you guys are able to hear, okay, I'm good. Uh,
It's audible, ma'am.
you're good, right? Okay.
All right. Okay. So let's. I mean, thanks whoever confirmed it. And again, one thing I forgot to mention, which I actually wanted to mention in the beginning, is like feel free to just stop me wherever I am and like ask questions. You don't have to type it in chat or something. You can just unmute yourself and like ask questions. I'd like this to be as interactive as possible. I want to make sure that it's very useful for you all. So do feel free to stop me. And so let me actually get into supervised learning. So we have some data here. This is pictorial data, and like there are three apples. And obviously the model doesn't know it. Kind of sees bits and bytes, and like it actually has like three JPEG files probably. And then somehow I have a methodology to label them as like, okay, these are apples. Then the model, when we give like a new object which is actually very similar to this, the model can predict that it's an apple. Correct? It's actually a very straightforward use case. Like I mean, just like us teaching students, right? Like we teach them like, okay, you know what, this is the answer to this question. And when we ask that question in like the examination, they actually write the answer and we can evaluate if it's the right answer or not. And there is unsupervised learning, all right, which is quite different from like supervised learning in the sense that we act all of these data to the model, and the model actually kind of learns something from it. So it in turn potentially learns that these go together, but it doesn't know that it's an apple because we haven't told the model, we haven't labeled the data, right? And these are peaches from Georgia, where I live in. So, and the model doesn't probably realize that like these are peaches, but it knows that these are similar looking things, whatever they are. And the bananas, again, the model kind of knows that those two are similar looking. All right. So that's unsupervised learning. The model learns something, but it doesn't. I mean, we potentially will not know what the model has learned, but the model does learn. All right. And what does it learn? It cannot learn like what the name of this is, or like what the if that it is a fruit. So what the category or classification of this is, and like this has calories, this is very healthy. The model cannot learn like things like that, right? Like it just kind of classifies stuff. So it can identify patterns, it can identify structures, right? Like it can identify like anything in this shape with like a green and a red combination is potentially goes together, while a similar shape but green and orange combination also go together, right? Like it can do something like that. It can create structures and it can create relationships like, okay, these three are related, these three are related, and these two are potentially related. Even if there was a banana with like not four of them, but just two of them, it will potentially place it there and like say like, okay, there is some relationship between these two, right? Now let's come to reinforcement learning. And then that's like someone said, like, is it AI? Yeah, it is AI and like it is human like. And we call it agent driven. I'll get more into depth on reinforcement learning in a couple of slides. So I don't want to spend like a ton of time here. Um, and the third one, which I also believe is like a very important thing to keep in mind whenever it comes to reinforcement learning, is it is a controlled environment. All right. So, and what do we mean by human-like learning? So, if we take a child and they probably have like some sort of object in their hand and like mm, they drop it and then they actually try to grab it back and then they actually drop it again. The third time they pick it up, they actually probably switch their positions to hold it in a little firmer way so that they don't drop it again. As like adults, what we do is like I mean, let's say we actually go and take like the 8:30 a.m. train or bus to work, and we found that it's like extremely crowded. Whereas like if we take an 8:15 train or bus, we find that it's like not as crowded and like it's very pleasant. So we learn from that. Like I mean, and we go at different times. Like let's go at 8, let's go at 8:15, let's go at 8:45, 8 9 o'clock, right? And finally we kind of pick like by trial and error the right time that is more convenient for us to ride the bus to work or something like that. So that's kind of the trial and error based learning that models can also do, which is now called reinforcement learning. And it it's just typically the word, right? Like we try to do things again and again using different ways and figure out like which suits us the best. All right. So now let's dive a little deeper into each of these models. Before that, I want to pause and ask any questions. I mean, if you have any questions till here, I mean, because going forward, we'll probably be diving deeper into each of these sections. So if something is not clear, like, I mean, if you don't understand the difference between labeled or unlabeled, if you don't like get something, feel free to pause. I mean, stop me. It's completely okay. Okay. I think everyone is probably either dozed off or everyone has like a very good understanding. So let's talk about unsupervised learning. And just to make sure like many of you have not dozed off, I'm actually going to ask you like a few questions. All right. So unsupervised learning, like I said, it learns patterns from untagged data or like unlabeled data. So what does that mean? And how does the machine use it? I'd like for any volunteer to go and explain like, okay, if the machine learns something, how can it use it? And what does it mean that the machine has learned it? Any volunteers? If not, I'm going to
Probably
call you.
whoever answers will make Mrs. Ranjani give a gift to them.
Sure.
Sure.
I mean, and there is no right answer to this. Just like, what do you think? Like, I mean, if I teach my little son something, right? Like I would expect that I mean, and let's say he has learned it, I'd expect him to use it, right? Like, I mean, if I teach him like math, or if I teach him like not to spill his food, then my expectation is like he will not spill his food, or like he will use math when he grows up or something. So why would we teach a machine? Is it like some sort of charity? Like, I mean, humans are also learning. Let machines also learn something, right? Is it the use case? Nobody wants to go. Or is anyone shy? Don't feel shy. I mean, like I've asked like really very dumb questions. Even I mean, I do that even now. So let me actually call some names. How do I? Let me. Okay, I'll not torture everyone. but but I mean, if any of you are like game, feel free to answer these questions. If not, I'll go ahead. All right. So let me answer them for you. No worries. So this means like the machine, I mean, at least when it comes to what does it mean, right? Like the machine can identify patterns, classify data. It can learn something. Just like when when we actually see something and we don't even know what it means. Let's say there is this big ball of some sort of thing, and we don't know what it is, but like it's like kind of lying on the floor here and there. Then we can actually see something, and like we can realize like, okay, if I go to this place, there'll be like these big green balls lying on the floor, right? It also like kind of recognizes some sort of relationships, right? Like probably like I don't see those big green balls lying on the floor everywhere. I only see it in like one of my friends' houses, right? Like so that means like I can also learn like, okay, I don't know what those big green balls are, but I know like if I go to this friend's house, I can expect to see a lot of those big green balls lying on the floor. I've learned something, not that I know what those big green balls are. Is it useful for me? Is it good for the environment or anything? But it actually is potentially very useful for me at some point, right? So now, how does the machine use it? Right? Like, I mean, okay, I showed you a label of apples, oranges, bananas, right? Like when the machine classifies it, we can label them and then at some point use them. What about the data sets that we cannot? I mean, like most of the data sets in the world, we cannot label it. I mean, like let's say we have medical notes, or let's say uh, Alexa has like Alexa is like listening to us all the time as we speak at home. I mean, like Google is listening to us all the time as we speak at home, and things like that. So what? How do we use it? So that's where like certain areas where like we don't even kind of know things yet, like recommender algorithms, pattern recognition, anomaly detection, and even segmentation, right? Like these are areas where we can use the machine's unsupervised learning. All that we provide is like some sort of input. I'm just going to send the machine like 10,000 pictures that are randomly downloaded from the internet. All right. And then I'm actually going to host all of these 10,000 pictures in a, let's say, website. And then let's say Rupa and like Mrs. Ranjani come and like they download um, a lot of these pictures, and the machine realizes like, okay, whatever pictures Rupa is downloading, it that's what like Mrs. Ranjani is downloading too. And like so it's automatically going to recommend whatever pictures Rupa has downloaded to the others, right? Like so those kind of things, we don't even have to have that intelligence as humans. Machine can automatically learn and apply it, and it's literally used in the example that I stole from Rupa, which is Amazon's unsupervised learning example, which actually kind of whatever you add to cart, you actually get like a lot of other things that other people buy, which is, I mean, and potentially if there was something that's, I mean, that's like not very, not supposed to be shown to every user or something like that, then like probably there will be some sort of rules and like algorithms that protect people from like viewing it. But most likely these unsupervised algorithms are used in recommendations where like we as humans cannot like kind of figure out like frequently bought together or like what you would like to see. I mean, Netflix uses this like for providing you with the right movie that you want to watch and things like that. It'll be very cumbersome for some 10 or 15 people team to actually recommend movies to like millions of people. So those are the areas. So now let's actually go into supervised learning. I mean, we saw like unsupervised learning, it is being used in like specific use cases. And honestly, other than recommendations and classification, imagining use cases itself is like difficult. I mean, the students you teach are all going to be much younger, and they may actually have very good imaginative power to imagine use cases for unsupervised learning rather than older people like me. So I would say like if we teach them these models, they'll actually find use cases for sure. So when it comes to supervised learning, this is like what is used in the industry like a lot today. And what is supervised learning? So supervised learning learns from labeled data, which means let us say I actually provide some sort of inputs like, okay, this is like the square feet of the apartment. Let's say this apartment is 10,000 square, I mean, 10,000 maybe not, maybe 1,500 square feet. And it has a swimming pool. The apartment community has a swimming pool, and it's also like 24-hour security or something like that. And that is like 1 crore. And this apartment is like only 800 square feet. It doesn't have a swimming pool, but it has 24/7 security. It is like 70 lakhs or something, right? So when it comes to things like these, the price itself actually acts as the label. And each of the identifying features, whether it has a swimming pool, yes or no, whether it has 24-hour security, yes or no, and what's the square feet, it's like 800,000, 1,200. Those are like the inputs. I mean, we as humans use these inputs when we buy an apartment. So we can kind of provide this data and like let the model learn. And at some point, uh, um, 99 acres or other websites that actually are used for like real estate in India, they are actually able to tell you like, you know what, this apartment is a quite a good deal because for this square footage with these facilities, usually the price is like 1.2 crores, but they have listed it only for like 90 lakhs. So you should be, it's a great deal, right? Like, so the machine is able to kind of point out to you deals like these. So that's where we actually have labeled data. We can train these models, and we ourselves can figure out like very easy and imaginable use cases for today. So like I mentioned here, right, like price predictions, demand forecasting, risk scoring, image recognition, natural language processing, all of these, right, like everything. I mean, image recognition is like what actually powers self-driven cars. Natural language processing is what powers like the digital assistants, Siri, Alexa, Google Home, etc. Price predictions, I mean, it's heavily used in the banking and investment field. Demand forecasting is used in like retail field, again, Amazon and like all online retailers, Flipkart, Walmart. And risk scoring is like our very own field, insurance and healthcare. We actually use these for risk scoring. All right. And the one thing that I actually want to also highlight in this slide is like machine learning is scalable. All right. So some of these use cases, right? Like, I mean, we can do this, we can write an algorithm, we can put it in Excel, right? Like how many square feet, whether swimming pool, yes or no, and like security, yes or no. And like we can make um, an Excel sheet with like, let's say even 1 lakh houses that were sold in like, yeah, in some city, right, in Andhra Pradesh. And like, we can actually kind of say like, okay, this is what it is. But let us say if one of us have to buy a house, then we will have to go through that 1 lakh rows and like try to imagine or like memorize all of it and like figure out like, oh, okay, it was like this probably could be At least swimming pool and like security are very easily relatable, but the height or like the floor of the building and like which area, these become like all the more complex. And if we now imagine like we have like 300 features, like not just the three features that I said, like the square feet, swimming pool, and mm, security, but we have other features like area and like whether it's a gated community or not, and like what schools are there nearby, how far is it from a nearby hospital. When you add like more features like these, even our decision will become like very complex. And that is where, when we use technologies like machine learning, we can actually simplify a lot of our decisions. That's that's one of the things, that our brain is not as scalable as a machine, obviously, because the machine can still absorb like 1 million pictures and like then identify a pattern, but we will take much more time than the machine to do it. Just as simple as like a calculator being able to do very complex calculations in like less than a second, while we if we have to do the same thing, we'll probably take like several minutes or even hours. All right, let's move on from supervised learning to the next one. I believe there was interest in this area, so let me again, like if there are any questions, do feel free to ask me. So what is reinforcement learning? It's in very simple language, if we have to say, it's learning using trial and error. And if I have to say, like, it's just like learning using trial and error. What does it mean? Let us say I have to go from my home to like my community swimming pool. It's about half a mile away from my home. And because I've done this several times and I'm considerably a decently intelligent person, I know like I'll have to walk straight and then I'll have to turn right and turn left, and then I can see the swimming pool on my left. All right. But if I did not know that, then I'll probably like walk straight and like make a left, and then I'll go searching for it. Ultimately, I'll find the swimming pool. But then I might have traveled like more than 2 miles to get to the swimming pool. The next time I take a different route. The third time I take a different route. The fourth time I take a different route. And I realize like every time I take these routes, either like the route gets longer or shorter. And there could be other things too. Like I may actually have to like jump someone's fence or something, which is actually wrong. Right. Like so those are things that we actually can be called a penalty. So if I really jump someone's fence and go to the swimming pool, then that can be penalized. Whereas if I don't have like any traffic lights, or like if I don't have to cross a very busy road, that can be considered a reward, because even children can actually then go to the swimming pool, right? So those are the things that we would do as humans. And again, that's how the model learns. So why would we need a controlled environment? So let us say if the self-driving car Tesla actually had to use reinforcement learning, and the very first time we actually kind of set it out in like a busy street, it can actually kill people. It can kind of kill the people sitting inside the car, kill the people that are like walking on the road, like other bikers. It could crash into a truck, it could crash into a home, whatever can happen, right? So if a Tesla has to learn to kind of drive itself, then it has to be done in a very controlled environment. I mean, and that's one of the reasons why like today it's not as much in use today as the other types of learning are in use. But what are like some easy and controllable environments that we have? When it comes to gaming, right? Like it's a very controlled environment. It's all simulation. Like I mean, you can probably like be walking on a road and down the hill or something in an animated game, and then like fall off a cliff, and nothing will happen. It's like okay, you'll get the next life, and like you'll learn that you'll have to turn left or something like that, right? So in the gaming environment, the environment is very controlled. Similarly, in robotics, actually, mm, let us say a robot falls down, uh, then or like a robot tries to pick something up. So and then it doesn't, it actually doesn't hold something very well, and like it drops it. the next time it tries to hold it even tighter, but then it crushes it, right? Like, so these kind of things you can do it in a simulated environment, and then ultimately have the robot fine tune itself to make sure that it's able to hold a cup or a mug in a way that is it doesn't drop it, but at the same time it doesn't crush it or break it. So robotic movement and balance are like one physical controlled environment. Online games, for example, like chess or poker, and if you're playing, if any of you do play IPL Fantasy League, many of the times, and if you play in like a, if you're playing it in like a paid version in like a small group setting, like let's say, or like in a 100 people group setting that is not filled until the end of the match, and suddenly you see like 15 people have joined your group, or like 72 people have joined your group, uh, then that means like all of those people are actually robots. And if some of them win, then like the company or like the people that built these robots have actually won the money. I hope that that actually answers some of the reinforcement learning questions that were shared earlier in chat. I am still going to keep an eye on the chat window. So any other questions at this point before I move on? Yeah, and as Rupa has mentioned, like feel free to type questions in the chat window and I'll be happy to answer them. All right, I'm going to move on to the next slide here.
Excuse me, sir.
Yes.
So every technology has its pros and cons. So
Correct.
what are the disadvantages with this reinforcement learning? If it has been widely adapted, then what are the disadvantages?
Eventually, correct. That's a very good question. At this point, the significant disadvantages like the non-existence of controlled environments for us to develop reinforcement learning a lot. Just like when we had 32-bit operating systems, the maximum memory that a system can have was limited to like 8 gigabytes or 4 gigabytes, if I'm not wrong, one of those, right? The moment we went to 64-bit operating systems, we actually ended up having the ability to upgrade our memory and like eventually process much more data. Like that, today reinforcement learning is not able to develop as much because it's not no, we don't have that kind of controlled environments. But let us say reinforcement learning is like extremely good, and like um, we actually have like a lot of things that have been automated and things like that. What could happen? What are the cons? Right? Like one of the biggest cons that I can imagine once reinforcement learning is like kind of business as usual is like humans will get extremely lazy. So when some of my friends actually asked me like, okay, there are like robotics and like there are development in AI and we may lose our jobs and things like that. I said like, yeah, I mean, if there is like all these robotics and like things like that, and I
Our
lose
health
my job,
problems will also increase, no, sir,
our health problem will definitely increase.
if we rely
We
heavily on robots.
correct with the invention of like cell phones and like especially post COVID with mass penetration of like working from home, as it is our health is like not doing great, and like I'm pretty sure like if we have like robots doing our washing our dishes and like robots kind of doing our laundry and putting our clothes away, dropping our kids to school and everything, then I think like we'll probably like not have the ability to kind of do as much. I mean, on the positive side, though, we can actually kind of focus more on like where human intelligence is needed more, and let the robots do like all of the irrelevant stuff. But at the same time, I'm not sure if there is like if we are even at a position to kind of uh, what do you call it, like not pursue like this incredible type of machine learning just for the just because like I mean it's like kind of not inventing a car just because like we feel like people will stop walking and they'll get unhealthier, right? Because we have like a car or a vehicle today, we are able to kind of transport emergency patients to like the hospitals much quickly because we have like helicopters. We are able to move people that are in immediate medical needs from one city to the other. Whereas like when these technologies were not available to us, people would just die, right? Like so these are technologies that actually are extremely enabling. At the same time, they have a tendency to make people very lazy. And probably reinforcement learning will actually come up with, the machine will come up with like some sort of intelligent way to make sure that it also keeps people active. I'm hoping. Does that answer your question, Ms. Ranjani? Okay.
Thank you.
Yeah. Yes, I think I don't know how much we have. Let's try to
All right. Yeah,
find
sure.
like 10 minutes. Yeah.
Sure. Definitely. So I have, I mean, we've discussed this in detail, but I just have a quick overview on like, okay, what is unsupervised versus supervised, and like specifically when it comes to like mm, the usage, like if we know like what we need to do, we will use supervised learning. If we don't know, then like we will potentially use unsupervised learning. So I will run through like a few of these steps. I mean, it's very self-explanatory. Data gathering, data preparation, data analysis and visualization. And then comes like the real machine learning, which actually is in modeling and evaluation. And finally, implementation, which is again IT or computer science as we today see it. So when it comes to data gathering, we actually have like only a few things to do, right? Like, I mean, first find data. And like, according to me, there is good data, there is bad data. If we have like very little data from a size perspective, it is automatically bad data. If you have a ton of data, it's automatically good data. And then like, do we have features like something that explains our target variable or like our labels? Are these consistent? And do we have a very good distribution, right? Like if we have data only for men, then we cannot predict anything about like women or pregnancy or childbirth or anything of that sort. If we have only data about women, then we may not like be able to predict certain things that are really specifically applicable for men. So similarly, and we'll actually have data storing and access, and these are all like things that today is very prominent: databases, data warehouses, lakes, and SQL is like a very widely used technology. And I'd say like ML terminologies, data set literally means like our data. A sample literally means like one row from a database perspective, and a feature usually means like one column from a database perspective, right? And we have labeled and unlabeled data, like I already mentioned. We have categorical data and continuous data. Categorical data could be like a yes or no type of question, or is it red, blue, or green kind of a question, or it could be continuous, like, okay, what is the price or what is age, things like that. And then we have text data for natural language processing. Ground truth is a type of data which is, as humans, we know it is true. For example, if we have a picture of a cat and like we know as humans it is a cat and we have labeled it, that becomes ground truth data. And it's usually applicable for image data and time series data. Now let's go into data preparation. I mean, and I actually stole this image from like A Cloud Guru. It's very simple, right? Like, I mean, you have, these are carrots and these are the same carrots, but these are like chopped off and like washed and like probably peeled and it's ready for consumption. Very similarly, we may have to kind of figure out like what is missing in our data, if we have too many duplicates, if we have invalid data, if we have to encode some of these data, meaning like the machine doesn't understand English. So we may actually have to categorize the data or classify them. So those are things that we have to think about when it comes to data preparation. And I'm going to run through like the next couple of slides and show you guys something more interesting probably. So analysis and visualization, again, courtesy A Cloud Guru. When we actually have to look at data, we want to make sure that we know like if there are two variables, we have to know like, okay, if there is some sort of relationship, and like in this plot, we see like a linear relationship. And if there are three variables, right, like we actually see like some sort of linear relationship, along with like if the number of claims are more, the time for processing takes more, and like the cost is also more, right? Like the size of the bubble also indicates something. We have information about composition of data, right? Like how many of them are like vegetarian versus non-vegetarian versus both, or something like that, right? Like, and when we have distribution related information, as well as, okay, how does data change over time? I mean, like we can see like trends. Does it increase? Does it stay the same? Things like that. All right. Now let us get into the real meat of today's presentation. I probably have like only a few minutes for that, but these are the steps in modeling. Like once we have gathered the data, we will actually split into training and testing. We will create a model or an algorithm and we will select it. And then we will train, test, tune, and then store the model. All right. And don't think I'm running because I'm going to dive deep into each of these in the next few slides. So what are some of the algorithms that we use? I mean, and the first one, which actually is a statistical modeling technique, which has been there for ages and been used by mathematicians since like the early 1900s. So that's regression. So regression is like literally like drawing a line in a graph sheet with the slope m and a y-intercept of b. So we actually have a formula y equals mx plus b. So if you know x, you can actually calculate y. So that is simple linear regression. When it comes to multiple linear regression, you'll have many x's and like many slopes. Classification is again a different type of modeling technique, which is like we classify as yes or no or red, green or blue, like I said. And for that, we use another type of regression called logistic regression. It actually tells us if it's a yes or no. Now let's look at some of the more newer technologies, right? Like all the way from here till here. So tree-based models, and why I have only these three and like not several other tree-based models, because these are the three that I use very frequently in my work and I'm able to easily explain. The others I have no clue because I haven't worked on much. So decision trees are like, again, some sort of decision making process in steps. Like let us say if we want to calculate the likelihood of somebody having a C-section or a cesarean delivery, right? The first step probably in the decision tree could be like, is this a man or a woman? And like you can right away decide that if it is a man, you can kind of say like he won't have a C-section delivery because he'll not even have a delivery, right? And then you go to the next step, which is like, okay, is this person over 80 years old? Is this woman over 80 years old, right? And like, yes. And then probably you can make another decision saying like, okay, they won't have a delivery. Then the third step could be like, is this woman less than 10 years old? Maybe they won't have a delivery either, right? So those are in steps, right? Like we actually make a decision. So those are decision trees. Random forest and boosting are two techniques that are actually extensions of decision trees, right? Like we deal with a ton of data. Let's say we have 10,000 row samples and we split it into 8,000 rows of training and 2,000 rows of testing. Which 8,000 rows we have used for training and which 2,000 we have used for testing could influence like the decision tree process. But what if we actually pick like the 8,000 and 10,000 again and again and again and again and like do multiple decision trees and like pick the average of those decision trees. That becomes a random forest. So, and boosting is again a very similar concept, but instead of using all of the variables, we use like a bunch of variables or like a smaller set of rows and like create multiple models. So, from a performance standpoint, you have a simple computer, you don't have like much CPU power, boosting is your way to go. Clustering is a type of unsupervised learning technique, and K means clustering is like one of the most popular unsupervised learning techniques, and that's something that we can go into detail. And then we have neural networks. We have like the simple neural network or the artificial neural network, which is very, it can be used in like all of these instead of regression, instead of logistic regression, instead of the tree-based model, we can use neural networks. It uses a human type learning process where we have neurons, hidden layers, and like there is a learning enablement. We have convoluted neural networks, and convoluted neural networks or CNNs are used in image recognition and object detection and any field that actually involves images. And recurrent neural networks are like uh, neural networks where like the hidden layers pass the information back and forth, and those are neural networks that are used in natural language processing. All right. So finally, going to evaluation and optimization, I do have um, like one example when it comes to like let's say a yes or no kind of prediction. Let us say we had 1,000 people that had a heart attack and 1,000 people that did not. If we had predicted 950 of the 1,000 people, while we actually predicted like 100 more that did not have a heart attack as somebody that did have a heart attack, and we missed 50 of the people that did have a heart attack, right? These would be your accuracy, precision, and recall. So recall is kind of very important here, because if we miss 50 people, we are missing an opportunity to save someone's life. And precision also seems to be a very important variable here, because instead of 100, if we had like a 500 people here, it is precision will go down, and it becomes a very expensive process for us to get all of them tested and like um, give them the attention. So in a healthcare context, we use these a lot, and that is one of the reasons why I felt like this would be important. So, I mean, Rupa, how are we doing on time? Would we be able to do like a couple of demos or?
Um, R- Ranjani, do you want us to go through the like a code demo, or we are done? Uh, Let us know. We can wrap it up now, or Sai can go a little bit into the code portions of it.
Yes, Swarupa. So I asked sir to explain the code for 5 minutes.
Okay,
Okay.
that is good. Yep. All right. So I will not get into painful details. This is a non-working model, meaning like it actually works, but I'm presenting it from like a different computer, so I cannot run any of these. But these have been run, and like I have a lot of information on what's available. So if we look at this model, I actually have like 870,000 row, what I would like to call a dummy data set, or like some sort of data set that I built using actual data, but I made sure it was not readable or like it was not usable. Um, I mean, for security purposes, right? Like, I mean, I don't want to share like with the entire world, like, hey, you know what, John Smith had a heart attack and his uh, one creatinine ratio was like 16 or something like that. It will be a breach of privacy. So I have like some random records here of 870,000 uh, people, dummy people. And we have like two types of records, like what was their hemoglobin level, what was their A1C or sugar levels, and did they have a certain disease and how long have they had it. Like 152 days would potentially mean like about 5 months. And like whether they're, what's their gender, what's their age. And the indicator here tells us like this person is 0, meaning they did not have a heart attack. This person is 1, they had a heart attack, right? And like I was saying, the first any model is to kind of make sure that the data is good. So I'm trying to see if there are any nulls, missing values, duplicates, and you can see a bunch of zeros here, which means like my data is good. And now I'm also trying to see like the distribution, like in some of the charts I showed you distribution. So here in this data set, I actually have like 86,000 people with who had heart attack in the past, and 160,000 people or 1.6 lakhs people that did not have heart attack in the past, but did have one or more of these lifestyle diseases. All right. And then what I've done is I've actually tried to analyze some of this data. All right. So first, what we can see here is we have data categorized by like gender as well as other areas. So it's very easily observable from this particular chart. I mean, any guesses on what's observable here? So what we can see is like a majority of the people that we picked that were men did have heart attacks, but that were women did not have heart attacks. So men in general tend to have a higher incidence of heart attacks compared to women. And that's a statistical thing or like a statistical observation that exists in the world today. The next thing that we have done is like categorize them by age buckets. All right. So if we look at like the heart attack incidence by age bucket, our bucket 0 and 1, 2, and 3 are like for age groups. I think the bucket 0 is like less than 20, and like this is 20 to 40, and like I think 40 to 70, and like above 70, or 40 to 60 and above 60. So above 60 seems to have like the highest incidence of heart attacks, 40 to 60 the next, but like 20 to 40 and like 0 to 20 seem to have like almost no incidence of heart attacks at all. I have a ton of variables or like features. Out of them, these are like the things that I picked. And some of these are called ICD-10 codes. And I can actually tell you, like, if you look at like the code I10, I10 stands for high blood pressure or hypertension. Then we see like we have glucose here, as well as like H1A1C. Those glucose and H1A1C are indicative of diabetes. So we can see some sort of correlation between like A1Cs as well as hypertension and several other variables here, right? So those are very observable parameters. So I'll jump right into the meat of the things. So we picked up a lot of variables, and I had spoken about train test split. So I split the entire data into like about 170 or 1.72 lakh rows as training data and 73,000 rows as test data. And the distribution between like heart attack and not heart attack is like pretty consistent for both of them. Now let us look at a couple of models. These are custom metric functions. So these are Python code. I will potentially point to like some sort of public resources that have these codes. All right. So the first model, like I said, is a logistic regression model. A logistic regression model can predict yes or no. So our prediction for this particular use cases, we want to predict, will this person have a heart attack? Yes or no. All right. And the trained data is what the model learns from, but the test data is something that the model hasn't seen. All right. So how does this work? We actually tell the model like, okay, you know what, learn from these 170,000 people or 1,72,000 people and predict on these so many people, right? Like 25,000 people or something. So, or 73,000 people. So what we see here is the model actually in the test is, I mean, and let's focus on the test, right? Like training is the model has already seen it. But in the test environment, the model actually has predicted 22,198 people as they will have heart attack, and they did have heart attack. All right. And the model predicted 991 people as, yes, these people will have heart attack, but they did not have heart attack. All right. So the third case is like the model said like, okay, these 3,580 people will not have heart attack, but in reality, they did have heart attack. And 47,000 people, the model said like they won't have heart attack, and they did not have heart attack. All right. Any, I mean, and I know I'm running, but any questions on this? So let us actually quickly look at the precision. So I've actually predicted here 95.7% of the people that will have heart attack 1 year before the incidence of their disease using their medical history. All right. Or I'm sorry, I'll take that back. Out of the people that I've predicted, 95.7% of them did have a heart attack. But did I predict all of the people that have a heart attack? No. I only predicted 86% of the people that actually had a heart attack. I missed 14% of them. I missed 3,580 people that would have had a heart attack. So that then becomes a question of like, okay, how good is this model? Is this even good? Is this even useful? So I mean, and Rupa and I always have this discussion. Like, I mean, are these models good? Can we implement them? And by the way, for those of you that doesn't know, Rupa is like my manager, so she's the one that I report to. So whenever we actually have these very interesting conversations, my argument to her is like, today we are predicting 0 people. Today we don't know who will get a heart attack. Like we don't know if anyone will get a heart attack or not. But I'm telling you, like these 22,000 people will get heart attack. I think that's better than 0, right? Like that has always been my argument for developing these models, getting some time for myself to do these research, and like kind of getting it funded from Rupa, right? Like so, that's the way we work. And like when it comes to these researches, we don't know if these researches will be successful. So it's a lot of investment when it comes from like management as well as like the company for people like me to spend a lot of time gathering data and like doing these researches. And our argument is always like, yes, we can provide something of value, but can we provide like everything? Maybe not. And we will try to improve more and more, like where we reduce this 991 and improve this 3,580, we reduce this and like increase this, right? So and we have done that even within this notebook itself. So let me actually go to like, so this is a support vector machine. I'll actually jump to, I mean, I showed you decision trees. As we can see, it did not perform. It actually picked up more people, but it picked up more false positives as well. Let me actually jump to boosting, or okay, random forest is good. So random forest is like a very good modeling technique. And here, as we can see, we have captured more of the people. Originally in logistic regression, we had only captured 22,000. Here we have captured almost 24.7K people. But we have also increased the 900 to 3,675. So then it becomes a decision on like, okay, should we still use this one or the other one? That's more a business kind of decision, but like the model can actually work better also. And at this point, right, like what is the most important thing that indicative of a heart attack? Age is number one. I-10 is like hypertension in ICD-10 terminology, and 4019 is hypertension in ICD-9 terminology. So hypertension also is a very common prevalence when it comes to heart attacks. And many of these are like lifestyle diseases like cholesterol, and 25,000 is diabetes. And there are other kind of things that could be like smoking or obesity here that actually play a very important role when it comes to heart attack. And let me actually go to like how. So we actually have the feature importances that we just discussed.
I think
Yeah.
we are out of time.
I mean, this is just the last portion of the model. So it'll like less than a minute. So when we compared like which model works best, we actually figured like the boosting model works best for us. And I mean, that's literally where I was about to stop. So we can actually literally compare like which model gives us better precision and determine like based on the use case which one we want to pursue. So that's pretty much what I had for today. And if there are any questions, I'm happy to take them.
Yeah, thank you very much, Sai, for partnering with me. I know you are good at showing all the code and the cool stuff.
Thank you.
So thank you for taking it in the last minute and coming up.
I think this is a very good opportunity for me to to shake off my fear and
Mm.
do some presentations. Thank you for the opportunity.
Yeah, Mrs. Ranjani, back to you.
Thank you, Mrs. Swarupa and Mr. Sai Nateshan, sir. So thank you. In spite of your busy schedule, you have spent a lot of time, your valuable time with us by explaining, by sharing the knowledge you have. I thank Mrs. Swarupa for explaining how AI and ML can be used to predict the diseases and health conditions of a person by using real time use cases. And also, she explained how the lives of people can be saved with the help of technology, that is AI and machine learning. And also, what is the skill set required for a data scientist, and what is the importance and what is the future of artificial intelligence. And I am also very much thankful to Sai sir. So for clearly explaining what are the types of machine learning. So your main emphasis is on machine learning, sir. So thank you. So you have clearly explained what are the different types of machine learning, and right from how to what are the various steps in modeling, and also what are the various steps in modeling, what are the different types of algorithms that can be used. And also, you have clearly explained with the help of the data set. So, how a data set, you have taken a data set and how various algorithms can be applied on the data set to do the prediction. So, thank you very much, sir. Even though both of you are related to industry, so you have explained very clearly, more than a faculty, more than an experienced faculty. So, thank you very much, sir. So for readily accepting my invitation, I am very much thankful to Swarupa for accepting the invitation, and also for recommending Sai sir. So she told about you, sir. Thank you, sir. And also I request the participants to give their feedback.
It was a great session, Rupa ma'am and Sai Krishna sir. It is definitely very helpful for all of us, those who participated in this faculty development program. The session was very informative, very interactive, and all the concepts that you have discussed was very clear and understandable, sir.